Our our presentation topics will be a fuzzy logic and its application. And I'm one of man, Chris, and my friends are Suk Kwon, Alice, and Yam Chong. And I will be responsible for the part of about theory, a very basic and very fundamental theory. And my friend will be responsible for the application part. And the aim of the theory will be just to provide you an implication of a new picture about a logic different from Boolean logic. So let's start now. So what is the basic of fuzzy logic? The term fuzzy here means there is some uncertainty in English, and we probably learned in ELEC001 that is the logic is a type of Boolean logic that's either 1 or 0. But in here, there's a big difference. In our lectures, the Boolean logic is only 1 and 0 only, and we will find that in fact this kind of way to say either a situation is however, in most situations in our world that we cannot just describe a situation in either one of the two ways. So we want to include a new features that we can describe the real situation. For example, to define the meaning of height or define a meaning of tall. Whether a person is tall or not cannot be described in Boolean logic. We can see why. First of all, let's think about what's the meaning of tall in our daily life. An ideal thinking is that every person that is taller than me, then I would prescribe he or she as tall, and conversely, shorter than me is short. But this is not a universal standard. It's easy to see. And more broad logical thinking is that we introduce a standard that is a conventional standard, and everyone will accept it, so that whenever a person's height is larger than a certain standard, say 190 cm is a standard, then any people higher than this height is described as tall. However, if we do in this way, although it is now a universal standard, then we will have a situation that is, how about 189 cm? Is this tall? If we follow the logic thinking here, that it seems logical that 189 cm will not be described as tall. And similarly, for some cases, 188, 187, then this problem seems to be unsolved. So we call, if we do Boolean logic, then we will have the following pictures like this. Any person that is higher than 190 cm is described as tall, and we can also include another universal standard 170, who is shorter than 170 cm is described as short. So what is the problem? It's immediately shown here. In reality, this is not the case, especially for boys who is about 189 cm will complain about this. So how can we solve this problem? In Boolean logic, the picture will be in this way. It's either you are either tall or you're not tall. You are just average or short. So to improve this, we call in reality. The reality is that 190, 189, and 188 is both tall. And however, when it becomes 185 and 180, we will again not certain. So we have to include the factor not certain. And similarly, for the person with a height of 160 cm is definitely short. However, for 170, it's become uncertain again. So, conclusion is that there is always some area that we cannot put it in either tall or average, or short or average. So, we need some logic with uncertainty. There's term probabilistic, a big technical term, that when we do Boolean logic, the results is either true or false, and the results will describe it as a deterministic. The when we include a uncertainty, there will be no more a deterministic logic, and we call this type of logic will have a probabilistic property. So this is the way, one of the way that you can construct the problem. So what's now? Look at this graph. We will see that some regions are overlapping. For example, here and here. And in this region, the person with height in this region will become both tall and average, and we introduce an uncertainty here. And also, we will include a factor that is called a membership degree. That is defined as the how certain you are in such a group. For example, if I am 190 cm height, then the certainty that I will be in the group tall will be about 0.4. And if I am very tall, then the certainty that I will be in the group category, the tall will be 1. That is very certain that I am described as tall. So this membership degree is very crucial in fuzzy logic, and we do not find it in Boolean logic. And so, as I said, the definition is it measures the certainty of a value being categorized in a group, tall, short, or average. And this is because this introduction of this degree of freedom, or you can say, then it introduced a probabilistic nature to the logic, and now the logic is no more deterministic. So here is the basic, it's really basic principle of fuzzy logic, or what difference between fuzzy logic and Boolean logic. And in fact, we will see that in our market, lots of application, in fact, is using fuzzy logic, and my team will explain further.
In fact, fuzzy logic have a very close relationship with our daily life. Let's see how fuzzy logic makes things better. One of the well-known applications of fuzzy logic is rice cooker. As we all know that cooking rice very depends on temperature. We applied fuzzy logic in rice cooker to control the temperature. It takes the form of an if-then statement. If the rice is too hot, it is continuing to heat up very quickly, then the heating element needs to be turned down.